Hi there, welcome to this Mastercraft 1 Outcome 2 lecture. We're going to be carrying on with volume and surface area, and we're going to be looking at cylinders just now. Okay, so a cylinder is the shape of a tin of beans, and we calculate the volume of a cylinder by finding the area of the circle on the top or the bottom and multiplying by the height. It makes sense if you think about it. We know how to find the area of a circle because we did that last class, which is pi r squared. We know from that before. So we take that area, and if we multiply it by the height, then that will give us the total volume of the whole cylinder. Okay, so we know that the circle is pi r squared, and if we times it by the height, we then get this formula for the volume of the cylinder, pi r squared h. Okay, now if we were to find the surface area of a cylinder, that could be split into three parts. So we've got the circle on the top and the circle on the bottom. We've got the area of those, and then we've got the curved bit. So imagine that is the label around the tin of beans. Okay, now if you were to do a net of that, it would look like this. So when we're calculating the areas, we know that the area of a circle is pi r squared, and we know that this one is also pi r squared. Okay, that's straightforward enough. The curved bit is a bit trickier. The curved bit, well, this distance here is the length of that rectangle, and that has to go all the way around the circle, so that therefore must be the circumference of the circle. Okay, so we can call that 2 pi r for that length there. So that means that the area of the curved bit, the label, is going to be 2 pi r and then times h, so 2 pi r h. So we get these two separate bits. So the area of the top, pi r squared, area of the bottom, also pi r squared, and the area of the curved bit is 2 pi r h. So we get a total surface area of the cylinder of 2 pi r squared plus 2 pi r h. Now, you might be asked for the total surface area of the cylinder, or you might be just asked to find the curved bit. Okay, it just depends. So just to reiterate, this bit here is the two circles, and this bit here is the curved part. Okay, so there's two separate bits of the formula there added together. So let's just do one example. So this steel insert has a diameter of 0.3 and a height of 1.2. Find the volume and the curved surface area of the steel insert. Well, firstly, we need to take this information here and we need to transfer that to the cylinder to help us. So we've got a height of 1.2 and we've got a diameter of 0.3. So the diameter, remember, is all the way across the middle. Now, that means that the radius is halfway to the diameter, so the radius will be 0.15. So just be careful about what it's asking. Okay, so firstly, we'll find the volume. So the volume, if you remember from the first slide, is pi r squared h. So that is going to be pi times r squared, so that's going to be 0.15 squared times by the height, which is 1.2. So I'm using the pi button on my calculator. You might want to use 3.14. So you might get a slightly different answer, but that's fine. And I get a volume of 0.085. And that, because it's a volume and we're in centimeters, that is going to be centimeters cubed. Okay, so that's the volume calculated. We're now going to calculate, it says the curved surface area. So it's not looking for the whole surface area, it's just looking for the bit around here. So the curved surface area, that part of the formula, if you remember from the previous slide, is 2 pi r h. So we just now need to put the numbers in the correct place. So it's going to be 2 times pi times r, which is 0.15, times h, which is 1.2. Okay, and that gives me 1.13. We're in centimeters and surface area, so it's squared. Okay. So just be careful with these because you might be asked for the curved surface area, you might be asked for the total surface area. Okay, if in this question you're asked for the total surface area, you would then add 2 circles on top and bottom by adding pi r squared twice onto this amount here. Okay, so we're now going to be moving on and looking at the cylinder worksheet on Moodle. If you could have a look at that, and I will put the answers up later. Okay, thanks very much.